Very good morning, students. Welcome to IIT NEET Foundation for Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches, class 9 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9. Our ongoing chapter, Gravitation. And today we are entering into the session number 2. So this chapter, as the 9th class students are already started for 10th class, these chapters are helpful for them in the 10th class public exam also. So when you heard the word gravitation, first we recall Newton sitting under apple tree, apple fallen down. That is a basic concept for the development of a huge branch of physics called gravitation, right? So before Newton, so many persons might have sat under apple tree and apple may fallen down, but nobody thought in that way, the way Newton thought. So because of the thought process, we got a big branch of one part of physics called gravitation. And there are so many scientists are involved in the development of gravitation, and they put their effort to propose so many important laws and all. Not only Newton, Kepler, Tycho Brahe, and many more scientists are involved in the development of gravity. So we'll continue where we left in the last class. But before that, when you recall what you learned in the last class, just same thing what we learned about what is a gravitation and what are the factors influence the gravitational force, for which Newton proposed Newton's law of gravitation, where he says that the force, what he says that every body in the universe attracts every other body with a force called F, right? And that force is directly proportional to product of two bodies, right? Suppose say it is M1, body of mass M1 and body of mass M2, and they are separated by distance of R. Between any two bodies which are separated by distance, the force will come into play, right? And this force is directly proportional to product of their masses. If their masses increases, the force also increases. And this force is inversely proportional to square of the distance between them. That is also called as inverse square law. You can call it simply as a. Okay. So this is second statement. So when you combine these two, you can write like this. F is directly proportional to M1, M2 by R square. Or to remove the proportionality symbol, you have to use the constant. Capital G is used as a constant. M1, M2 by R square. So this is called Newton's gravitational law, what we discussed in the last class. So what is G here? Is a constant. Universal gravitational constant. What is called? Universal gravitational constant given by Fr square M1, M2. Just we want to calculate G means we have took the R square this side, M1, M2 denominator. From this, the units of G is, your value is constant value 6.67 10 power minus 11. And units are F, Newton, R square, meter square by kg into kg square. Unit of G, Newton meter square by kg square. Right? So this value is called as a universal gravitational constant. This value is constant everywhere in the universe. Whether you go to Sun, Moon, planet, Jupiter, Neptune, anything, wherever you go, the capital G value remains constant. Right? That is given by the Newton's gravitational law. Newton's universal gravitational law. So according to Newton, every body in the universe attracts every other body with a force called gravitational force, right? The force called gravitational force. Okay, and this gravitational force between the two bodies is directly proportional to product of this directly proportional to product of their masses and inversely proportional to square of the distance between them. So there are so many scientists how they involved. We discussed in the class, and this is the law where we completed, right? So there are properties also there for gravitational force, how it changes. So gravitational force same only everywhere. Then next part comes is another important term. Suppose when I am dropping a body, suppose this is pen in my hand. I am dropping. So what is the velocity of the pen in my hand? Zero. I am dropping the body with a zero velocity, but still it is moving towards the earth and touches the ground. Why? Because of the gravitational pull, the body is accelerating from zero to some value. That acceleration produced in a freely falling body due to gravitational pull of the earth is called acceleration due to gravity. What is that? Acceleration, very important terms which reads the total chapter. Acceleration due to gravity, which is small g. Capital G already we have seen. Universal gravitational constant. Now it is the small g. The acceleration produced in a freely falling body due to gravitational pull of the earth is called acceleration due to gravity, that is g. So g on earth, surface of the earth is approximately 9.8 meter per second square. How will get? I will tell. How much? 9.8. Right. G on earth. G on moon is 1.67 meter per second square. The G value on sun. G value on sun is 27.4 meter per second square. So it depends on the mass. G on Jupiter is 29.4 because Jupiter mass is very heavy, second square. So the G value, what is observed here, is changing. It is not same like capital G. Capital G value is 6.67 10 power minus 11 everywhere in the universe. That is called as a universal gravitational constant. Whereas the pull of the earth is different. So earth will pull sun with different acceleration. Earth will pull moon with different acceleration and Jupiter with different acceleration based on their masses. Because it depends purely on the product of their masses. So acceleration due to, for example, your weight. You are weighing 60 kg on earth. You check it with your machine. The same weight you are weight when you go to the moon, it becomes 1/6. That is, you become only 10 kg. Right? Becomes only 10 kg. Why? Because the G value is 1.67 there, which is 1/6. The G value on earth is 1/6 of the G value of moon. 1/6 of the earth. That's where weights also become 6 times less. When you go to sun, if you can, we cannot go to sun. We cannot go to sun because if you go to sun, you become ash only. If you go to sun, your weight becomes 3 times more than your weight. It becomes 180 kg because the sun G value is 27.4. Similarly, Jupiter also. Right? Clear? So G value, G is nothing but the acceleration produced in a freely falling body due to the gravitational pull of the earth is called acceleration due to gravity, whose value changes from place to place and planet to planet. Even on earth also, there is a slight variation. Some conditions will change the value of G from 9.8 to up to 10. When you go to the height, when you go to the depth, when you come to equator, when you come to poles, the value slightly changes. Right? Some cases it becomes zero also when you go to deep into the earth crust. That we'll discuss. Factors are there. But capital G remains same. Then what is the relationship between the capital G and small g? Right? You see the relation here. I'll tell you. Say, so this is the earth. Right? Whose mass is capital M. And we place one stone here. Stone above the earth, the mass of small m. And they are separated by a distance of, say, capital R. Right? Because everything is capital, big. Earth of mass capital M. And we kept a stone of mass small m here with a distance separated by R. Then what is the force acting here? The force acting between the stone and the earth is given by F is equal to M1, M2. What is M1 here? Capital M, small m. M2 is small m by R square. That is equation 1. This is for the gravitational force. Same time, when you recall Newton's second law, F is equal to ma. So what is A here? Acceleration. But as we are discussing about gravitation, it becomes F is equal to mg. A becomes g. So equation 2. This is also gravitational force only. This is also gravitational force only. So you can equate 1 and 2. 1 and 2 are same. 1 is equal to equating. That is, we can write it as mg is equal to gmm by r square. Correct? Sorry, capital R square. Because radius of earth is capital R. So distance you have taken from the center of the earth. Okay. Then you can cancel the masses. So we get G is equal to gm by R square is the relationship between the small g and capital G. You can get the G value. Why? Because we know the capital G value 6.67 10 power minus 11. M is the mass of the earth. R is the radius of the earth. Those are the constant values. We can get the values later, you. So by substituting the mass of the earth and radius of the earth. Radius of the earth is around 6 into 10 power 9 something is there. Similarly, mass of the earth also. To substitute these two values and G value, we can get small g value as 9.8 meter per second square. So from relationship between capital G and small g, we can get the value of small g because all three values we know. We know the capital G, we know the mass of the earth, we know the radius of the earth. So the relationship is given by G is equal to gm by r square. Same case, see, this is for example, we are taken for the earth. So E should be there. Suppose if you want to go for the sun value also you can get there. So if you want to go for sun, G of sun is equal to, G is capital only, M of sun by R of sun square. You know the mass of the sun value is there. We know radius of the sun. G value is same only. Then we get the GS is equal to 27.4 meter per second square. Similarly for moon also you can write mass of the moon, radius of the moon. G value is same. We'll get the moon is equal to 1.67 meter per second square. Jupiter, any planet, any body you can calculate by using the value of G by using this formula. As you know, all the three values of right side, definitely you get G value of sun, G value of earth, G value of Mars, G value of earth, everything we can calculate. So this relationship is helpful for us to calculate the so many values of acceleration due to gravity that is given here. Okay, gm by r square, where g is the universal gravitational constant, m is the mass of the earth, r is the radius of the earth. Right? And some more here. See, you can convert in some other way also. Very interesting way. Right? See, we know g is equal to gm by r square. So, m, what is m here? Mass, we know density is equal to mass by volume, we know. So mass is equal to density into volume. So density of the earth we written, density into volume. So what is the volume? So density is, I generally wrote rho here. This is density. Volume is volume of the sphere. Earth is sphere. Volume of the sphere is 4 by 3 pi r cube. In place of volume, 4 by 3 pi r cube. And density is nothing but he wrote density represented by rho here. So these two gives the mass. In place of mass, you can substitute the 4 by 3 pi r cube rho. That he done here. G into 4 by 3 pi r cube rho by r square. And you can cancel out r cube is there, na? R cube is there. You can cancel it, r square and r cube. One r will be there. So finally we get the formula. Small g is equal to 4 by 3 pi rho gr. Simple. In place of mass of the earth, we wrote volume into density of the earth, which is also known values for us. Right? So the relation can be either we write like this or like this. See, clearly mentioned in the bracket also. So this mathematical formula is helpful for solving many numerical problems in a higher classes, even in the IITs also. Clear? In main IITs also you can come across such formula. You can use that formula. You are not only in the gravitation, that formula is also helpful in the kinematics, dynamics also. We have to use that formula to find out the value of G at any place, at any conditions. Because there are various factors are there on surface of the earth where the G value slightly changes. Not much. We are saying it is a 9.8. It is not exactly 9.8. It may be 9.8 in Hyderabad. When you go to the America, it may slightly changes. Why? Because of the atmospheric conditions. It may become 9.9. When you go to the Himalayas, its value may be 9.6 only or little less. Not much variation. When you go to the height, when you go to the depth and the local conditions, coldness, hotness, also slightly changes the G value on surface of the earth. Then we'll see what are the important factors which influence the conditions. So before that, you can see some important points are there. From the expression G is equal to Gm by R square or this, it is clear that the value depends upon the mass, right? Mass, radius and density of the planet and independent of mass. Shape and density of the body placed on the surface of the planet. That is, given planet reference body produces. Means from this formula you can understand the value completely depends on the mass and distance. So the greater the value of m by r square or rho r, the greater the value of the G. The acceleration due to gravity is a vector quantity and is a direction always towards the center of the planet. So dimension formula is LT minus for G. Acceleration. Velocity by time you can write L by T square or LT minus 2. Its average value is taken as 9.8 meter per second square or 981 centimeter per second square or 32 feet per second square on the surface of the earth at mean sea level. You go to high level or down, changes slightly. Okay. So this value, the value of G, the slightly changes with the some factors like C. Shape of the earth, because earth shape will change. It is different at the poles than equator. At poles, the G value is maximum, 9.8. But when you come to equator, the G value is minimum. It can be 0 also. And height above the surface of the earth, depth below the surface of the earth, axis of rotation of earth. Under all these conditions, the value of G changes. So how it changes? Before explanation, before theoretical explanation, I will show you the video on what are the factors influencing the value of small g. Remember, it's a small g, not capital G. Okay. Capital G is always constant.
Acceleration due to gravity. Free fall. When an object falls towards the earth due to the earth's gravitational force, it is called as free fall. Earlier, it was thought that the lighter bodies fall slowly while heavier bodies fall rapidly. For example, If a feather and a metal coin are dropped simultaneously from roof, the metal coin would reach first and the feather later. But it was Galileo who has proved from his experiments conducted from the Leaning Tower of Pisa that objects of different masses and sizes, when dropped simultaneously from the same height, would reach the ground at the same time. That is, when an object is dropped from height, it experiences uniform acceleration by the gravitational pull of the earth, and this acceleration does not depend on the mass of the body. Let us define acceleration due to gravity. The acceleration due to gravity is the uniform acceleration produced in freely falling body due to the influence of the gravitational pull of the earth. The acceleration due to gravity is denoted by g. This value varies from one celestial body to another. For example, the acceleration due to gravity would be different on the moon as compared to the earth. Similarly, you would have different values for Jupiter and Pluto. The unit of g is same as the unit of acceleration, ms to the power of minus 2. Value of g. From the second law of motion, force is the product of mass and acceleration. F is equal to ma. For free fall, force is the product of mass and acceleration due to gravity g. F is equal to mg. We know from universal law of gravitation, F is equal to g into m by d square. mg is equal to g into m by d square.
dr
G is equal to gm by d square, where m is the mass of the earth and d is the distance between the object and the earth. For objects near or on the surface of the earth, d is equal to the radius of the earth r. mg is equal to gm into m by r square, or g is equal to gm by r square. To calculate the value of g, we should put the values of g, m and r in the equation g is equal to gm by r square. Universal gravitational constant g is equal to 6.673 into 10 to the power of minus 11 nm square kg to the power of minus 2. M is equal to 6 into 10 to the power of 24 kg. R is equal to 6.4 into 10 to the power of 6
radius of the earth.
G is equal to gm by r square. G is equal to 6.673 into 10 to the power of minus 11 nm square kg to the power of minus 2 into 6 into 10 to the power of 24 kg by 6.4 into 10 to the power of 6 m whole square. The value of g is 9.8 ms to the power of minus 2.
Substituting all the values, see, g value is constant. Mass of the earth is 6.6 in 10 power 24 kg. Radius is 6.4 in 10 power 6 meter. When these two value changes, the g value changes for sun, moon or everything, right? Right. So this is how to calculate the, some more factors are given here, you can understand.
To focus on acceleration due to gravity, which is denoted by g, and factors affecting the g. And this g is a small g, not capital G. Capital G is for gravitational constant, but this small g is acceleration due to gravity. What is it? Acceleration due to gravity can be defined like this. Acceleration developed on a freely falling body due to the gravity of the earth is called acceleration due to gravity. Look at this word, freely falling body. It means there is no any resistance, and acceleration due to gravity is possible only in vacuum. In air, the motion of the body will be obstructed by the air. Okay, its average value is 9.8 meter per second square. Okay, we can understand this very clearly like this. If a body is dropped from certain height, it will certainly fall in a straight line. And first, its velocity will be 0 when it is not dropped And when it is dropped exactly after 1 second, its velocity becomes 9.8 meter per second. And at the end of second its velocity increases to 19.6 meter per second. And at the end of third second, its velocity increases to 29.4 meter per second. Every second velocity is increasing and increasing and increasing. And this increment is of 9.8 meter per second. Look at this. In first second, increment is 9.8. In second also, 19.6 minus 9.8 becomes 9.8 meter per second. Here also 29.4 minus 19.6 gives 9.8 meter per
The
second. Every
uniform
second
acceleration.
velocity goes on increasing, and this increment is by 9.8 meter per second. Because of less velocity in first second, it covers less distance, but in second it covers more distance because of more velocity, and in third second it covers more distance. Since velocity is increasing, that's why distance covered in every second will also be increasing, and its acceleration will be 9.8 meter per second square. This is acceleration due to gravity. I want to tell you one another matter also. When a body is dropped from very great height, at this time also it falls down in a straight line, but it falls in such a way that every second its velocity goes on increasing this way, and it covers more and more distance. In first second, if it covers this distance, second more, third second more, because its velocity is increasing and increasing. The reason is very simple, because it is pulled by the gravity of the earth. Earth pulls it towards its center, and because of this gravity force of the earth, the body accelerates. Acceleration never produces without the force, and gravity force is responsible to produce acceleration on this body. But when its speed increases in the air, then air resistance also increases, and air resistance acts in opposite direction, which is against the motion of the body. So air resistance goes on increasing due to the increase of the velocity of the falling body, and a condition comes when air resistance neutralizes the gravity. When air resistance is neutralized by gravity, then the body begin to fall with uniform velocity, not acceleration, because force is seized by air resistance. That's why now it falls with uniform velocity. And so we can say that there is two type of motion. At the beginning, the body falls with acceleration due to gravity. But when air resistance neutralizes the gravity, then it falls with uniform velocity. Now let's talk about the factors which affects the value of g, small g. Number 1, the radius of the earth. Earth is flattened at pole and bulged at equator. That's why its radius is different in different place. Polar radius is less, equatorial radius is more, and its radius is different in different places, and accordingly value of g also varies from place to place. We'll talk in detail about the same later. G depends upon height from the surface of the earth. The height from the surface of the earth decreases the acceleration due to gravity. Value of g becomes less. Depth from the surface of the earth. As we go to the depth of the earth from the surface, let's say at this place, then the acceleration due to gravity at this place is less than the surface. This is very interesting. When we go to height, g decreases. When we go inside the earth, g decreases. This way g is maximum on the surface of the earth. Okay, axis rotation of the earth. Earth is rotating like this in its own axis. Because of this rotation, the value of g is less. Later we'll discuss about this also.
Okay, these are the 4 important factors which influence the value of g changes. But on surface it is maximum, that is on at poles 9.8. Either it goes to the height or it go to the depth, the value changes. That we'll discuss in the factors influencing in the by g, right?
Okay, let's go to another part. G is inversely proportional to the square of the radius of the earth. It is symbolically represented here. We are going to prove this. Acceleration due to gravity depends upon radius of the earth, first point, and we are going to prove this how it depends upon radius and y square of the radius of the earth.
Right. So we'll discuss. We'll see in the next class this one. So when you discuss C, variation of value, variation of G value based on the various factors. So first one you can see here. I mean, mathematically also you can prove how it decreases, right? Not only orally, we can prove the mathematically also. So see, the earth is not a perfect sphere, it is elliptical. Just now you are sharing the video also. So because of elliptical shape of the earth, radius changes. At some place radius is more, at some place radius is less. Radius is less towards the pole, but radius is more towards the on equator. So it is flattened at the poles and bulged at the out of the equator. At poles it is flattened. At equator is bulging. So because of that, the value of G changes. See, at equator, G at equator is given by Gm by R at equator. At poles, G poles is equal to Gm by R square. From 1 and 2, when you equate G pole by G divide. So what will get here? G pole by G equator is equal to, so this will be a formula from this. So from that we can get the what is the relation. By substituting these values, we can get the relation as there is a variation of 0.018 per meter per second square, less will get. From thus we can say that G is maximum at poles and minimum at the equator. The value of G decreases from pole to equator. When you come from the surface to the equator, here value is 9.8. When you go inside, the value becomes less, 0.18 or 0.18, almost equal to 0. So as you go to deep into the earth crust, the value of G decreases. That is clearly understand here. Right? Now, A is over. That is variation of G. Just a minute. Slope of the earth, as because shape of the earth. Due to change in the shape, the value of G decreases because the earth is flattened at the poles and bulged at the equator. The radius at the equator is more when compared to the poles. As you are going to the equator, due to increase in radius, as you know, you see G is inversely proportional to square of the radius. So G is inversely proportional 1 by R. Just now I have shown. Because G and M are constant, mass of the earth is constant. G value is constant. In place of G is equal to Gm by R square, you can write. So as the radius increases, G value decreases. So as your radius increases here radius is less. So here G value is more, here G value becomes this much less, 0.018. Even it becomes a 0 when it reaches the center of the earth. From here to center, the value decreases from 9.8 to even 0 also. Mathematically proven. Next, variation of G due to height. Suppose you are on surface of the earth. You are going to height. Okay. So acceleration due to gravity on surface, the formula you know, this is given. So formula becomes acceleration due to gravity, but h means the stone is at the height of h. So you have to add the radius is this and h added. So total r becomes r plus h whole square. Because height is there, you have to add that height also. As you go to the height, the influence will change. So this becomes. Then from here, we can write from 1 and 2. 1 is this, 2 is this. When you divide g of earth, g of height by g of G is equal to, dividing 1 and 2, we can get the one relation here. G into 1 minus 2h by R. If you substitute the values there, we know the G value, we know the h value, how much h is from the surface of the earth, we know the R value, radius of the earth, 6.4 into 10 power 6. By substituting, what we get? The value is the less than the 9.8. Why? Because the value is decreasing as per body goes to the height. So all these are the very influence factors, right? And similarly, when you go to depth also happens. In the rotation of earth also, we can find the change in the value of G. All this we'll discuss in the next class, right? Few more factors are there, followed by the important points. Okay. What are 4 factors? First, we discuss about the shape of the earth. Next, height. So next class, we'll see about the how it changes with the depth and how it changes with the rotation of the earth. Right? Followed by some more information about the gravity. Right? So that's all for today. What we learned about the gravitation, acceleration, and factors influencing the acceleration, relationship between acceleration and acceleration, the universal gravitational constant. Right? So thank you all of you. Have a wonderful day. Thank you.